I often say that in mathematics and physics, understanding is more important than memorizing. And these four identities, the sum and difference identities for sine and cosine, are a perfect example of that. We're all taught to memorize these identities, but we're never given a proof. We're just taught to take them on faith. I guess we're not given a proof because the proofs, the proofs for me were extremely difficult, the proofs that I came up with. But these four identities, particularly the first two, I guess, are fundamental to math and physics. They seem to come up everywhere and are the basis for other results in math and physics. So I think it's good to understand them. I mean, wouldn't it be satisfying to say to yourself you understand every fact you know in math and physics and you know where it comes from? I think doing so makes you a better mathematician and physicist. Certainly, doing these proofs of these identities made me a better mathematician and physicist. I do have a video on proving the first two of these, the sine ones. You might want to go and listen to that one before you proceed further in this one. In these four identities, A and B can be any angles, so any angles in the unit circle, positive or negative. That being said, if we take the veracity of this one here, the third one, cosine A plus B, if we accept this, we can prove this one. So pause the video, do that as an exercise. Assume this is true and prove this identity. All right, let's do it together. So this is the one that we're assuming is true, and then to prove the one for the difference of cosine, we'll simply plug in negative b for b. So here I'm doing it. I'm plugging in negative b for b, here, here, and here. And then since cosine is even, we get this. And then since sine is odd, we get this. So we're done. All right. So now we're going to prove the truth of this. I want to preface this by saying I've proved this over the years at various times, maybe when I'm sitting on a park bench or whatever, and then I forget my proof, and then I go back and do it. So this proof that I'm going to be doing, you could think of it as a subconscious synthesis of all my proofs and just my math and physics experience over the years. It's very difficult, the proof is, so it might take several days for the proof to sink in. You may have to watch the video more than once or pause it and maybe get out a pen and paper. All right, here goes. So I'm a visual person, so my proof depends a lot, well, it hinges on this diagram, the unit circle. Now I think of A as being measured first and then B being measured relative to A. So A serves as an x-axis for B, that's why I wrote this here. Notice in this diagram, B is negative, it's measured clockwise. Now, we're proving the cosine A plus B one, that identity. So the left side is the cosine of A plus B, so if we do A plus B, we end up at this dot on the unit circle, and if we're taking the cosine, we're interested in basically the projection of this dot onto the x-axis, and it can be positive or negative. So in this case, it's negative, like it's this distance from here to here. All right, here's just another scenario. Here's A and here's B, and we end up here. Now, in my proofs, I break up B into, I guess, components parallel and orthogonal to A, to this A axis. So here's a component and there's a component. And then for doing the cosine, we're just going to project these components onto the x-axis, right? We'll go here and here and then hopefully end up here. So to that end, think of B, first of all, just dissolve A. To collapse A, suppose A is 0, A doesn't exist, and we'll just springboard B off the plane of the x-axis like this. Now notice here B is negative, and this y component of B I've translated over here so it's at the origin. It might be simpler to think of B so it's in the first quadrant, so its y component's positive. You might want to actually think of it that way. I just did it this way because I didn't want to lose generality, but maybe think of the y component of B is here. Now, we have B, and then we're going to rotate it through A, counterclockwise, like this, because it's really springboarding from A. So when that happens, let's analyze what's happening to its two components. So, and particularly the projection of these two components on the x-axis. So on the right side of the identity in question, the first term is cosine A, cosine B. So think of this vector here as cosine B, right? It's basically the x component of B. Now if we multiply it by cosine A, so cosine B, cosine A, we're getting precisely what we want. We're getting the projection of this vector onto the x-axis, right? So it's this length here. And you can convince yourself that it will be positive or negative as it should be, this projection. All right, to project this, we're going to rotate it by a and then project it onto the x-axis. So it's like we're projecting this, but this onto the x-axis. So the second term on the right is negative sine A sine B. So think of this is like sine B, right? It's the projection of B onto the y-axis. If we multiply that by sine A, so we have sine A sine B. Well, let's get the negative sign in there. So focus again on the second term on the right of the identity. It's negative cosine A sine B. Negative sine A sine B. The negative is in there because, again, think of the y component of b as positive. If we're rotating this little diagram by a counterclockwise, then this vector here, this y component of b, gets rotated counterclockwise by a relative to this positive y-axis. But if we're multiplying it by sine of a, it's sort of as if this were the x-axis and this is the y-axis, but this is not the y-axis because it's a negative. That's why the negative sign is coming in. That's why we need not sine A sine B, but negative sine A sine B, because it's almost as if this is the x-axis for. Think of this as think of the y component of b now, and just think of measuring it relative to this axis. So it's sort of like this is the x-axis, and then this would be the y-axis. So then we would want to do sine b, because that's this component, times sine a, and that would be projecting it on to this x-axis. But again, since this is really a negative axis, that's why we have that negative sign in there. All right, that's the end of the proof. As I said, it may take many days to sink in. Could you please support me through PayPal to devinwyndham@gmail.com. And if I do tutor, both in person and online, I am based in Fairfax, Virginia. If you're interested in tutoring, you can contact me at this email.